see. Basically, this if I move up and down, my x will increase and decrease. Left and right, my z will increase and decrease. So, can you see how this works? Now let's see the RQT graph. Yeah, Gokul, it's the node publishing topic Gokul, and Joy is the node publishing Joy. This is from my mobile app, and my laptop's terminal is subscribed to it. Now let's do something. Now this same mobile, let's just subscribe in the code and see. Which code is subscribing to pool? My subscribe code, right? So over here, instead of object, I will make it Gokul. Now I will run my subscriber code over here. Python sub.py. Okay. Now when I press the button, you can see here. So it's coming true, false. So over here, it's when it's true, it is stop, and when I leave it, it's go forward. Is it clear now how to use ROS to publish command from your phone and use it in a code?
Yes.
Now imagine your Arduino is connected to it with a LED. So what you can do is when you receive something with Pi serial, you can send some data to Arduino. So when I click a button, LED will blink. On my phone, LED will blink on the Arduino. And if you use ESP, Node MCU or ESP, you can. I'm just telling you, I'm not going to show you how. I will send you resources for that. If you have a Node MCU or ESP, you can actually connect it to the same Wi-Fi and control use ROS serial in it and control your robot using ROS with your mobile in one wirelessly with the same Wi-Fi network. So this is how you can use it in your real hardware projects. So ROS is nothing, it's not a programming language, it's just a framework which allows you to transfer information between multiple codes and run multiple code parallelly. I hope now you guys would have understood how publisher subscriber works and basic idea of what ROS does and how each program can get information from other programs.
Yes.
Okay. Can I get like little more S's? If not, please type no. I will explain it.
Yeah.
Again.
Yes.
Yes.
Okay, cool. So let's just move to last thing, and after this it's done. You guys can sleep. I can also go home. So I told you integer and stuff like that, right? Similarly, if you want to have multiple data type, for example, wait, I'll give you an example. Okay, cool. So if I want, let's take cooking only as example. Let me just present my screen. Can you see my screen? So imagine in cooking there are two codes. Recipe, one more thing is cook. Now my recipe should send the publish basically. My recipe code should publish all the details of amount of ingredients for my cooking. Let's assume I'm just gonna cook one particular dish. So my cooking will subscribe to it and then will make all the dispensers to dispense that particular amount of ingredients. Now, if I in a recipe, there are multiple things, right? Like multiple ingredients, ingredient 1, ingredient 2, ingredient 3. Now, instead of me publishing a different, declaring A equal, for example, dhania 2 grams, coriander 5 grams, I will create one common message called as, let's say I'm making something, I'm making paneer butter masala. So I create a message called as paneer butter. And in this message type, I will pack float paneer, float butter, float salt, and then assuming this 3 only needed, I know it is not, but anyways, I don't want to type it. Now, when I will make this as one message, and then when I want to publish it, I will just do let's make it PB. PB is the message name, and this has this particular types. So what I will do, I will declare a equals to pb, like int a equals to pb. Now a dot paneer equals to 3.0, a dot butter equals to 8.5, something a dot salt equals to 1.2, and then I will publish my a. Now my cooking code will subscribe to a, and how it will get data? It will get data like a dot paneer, sorry, dispense a dot paneer. So this is how ROS packs multiple data types into one message. It's like your structure. Now you understood how custom messages look like. It's not ROS don't just have int float, it also has this packed messages.
Could you repeat this part again? What you just mean?
Okay, so for example, if I want to cook a recipe, I have to publish, like I need 3 ingredients. Every time, instead of creating 3 independent message type, I will create one message type called pb, and this will have subparts as this 3. So when I want to access salt, I will do pb, like a equals to pb, that is, yeah, I'm declaring a as a pb message type. It's like int a. It's similar to int a. I'm making a is as a pb message type, and a dot paneer, a dot butter, a dot salt. So my a has 3 subparts. I'm declaring value to these 3 subparts. So when I want to publish these 3 things, I don't want to publish paneer separately, butter separately, salt separately. I will just publish a, and a inbuilt has these 3 components, and this all will be published together as a pack.
Okay, thank you.
Did you get it?
Yes.
Okay. Now let's see a standard message like that. What is there? ROS message show / like standard message. There is something called geometry message. Like standard message has things like int float, like that. Geometry message has all these things. I'll just show you what is command will. Sorry, that's twist message. Sorry. Yeah. So this is my twist message. So my twist message has 2 different parts. One is linear, one is angular, and each of that part has 3 subparts, XYZ and XYZ. This message is generally used for controlling the robots. Like it can be, if it's a mobile robot, only linear X and angular Z will be needed. So linear X is for forward and backward motion, and angular Z is basically theta, how much the robot needs to rotate. And why the other 2 things are there? This is there for drones. If you want to like roll, pitch, yaw, and all these things you need, no? So that's why other things are there. But if you are using a mobile robot, only X and Z is all what you need. That's why in my joystick, when I published, when I go linear X increased and decreased. When I went side, angular Z increased and decreased. Do you understand what twist message is? Guys, hi.
Yeah.
Okay, cool. So now when you want to, let's say, make an actual robot to follow a line, and do you want to like pass commands using ROS, instead of you publishing PWM values, what you can do is you can just publish this twist message, and in the Arduino side you can subscribe to this twist message and get the PWM based on the calculation with X and Z, and you can move your robot. So yeah, so this is all I wanted to explain. Now I will also send you resources for how to make your custom message. I'm just giving you intro of everything, and I will send you resources for that. So if you are interested, you can learn about it. So in your project also, if you have like 5-6 variables, you can just pack it to an individual message like this, and you can send it. Cool.
Yeah.
Okay. Right. So I guess I will stop here. If I go further, it will be a lot of confusion happening because it's a new topic. So you guys can leave. If someone wants to learn something more, stay, ask me, I'll show you.
What about the problem statement
What problem statement?
for ROS?
Is there a problem statement for ROS? I don't think.
Last time it was not there. This time I don't know.
Anyone from IEEE team there? If it's there, I'll just send it in WhatsApp. I don't think a problem statement is there. You can just use this framework to do your projects. in a faster and efficient way. That's all.
Okay. What about gazebo?
Yeah. What do you want to learn? Like learn in Gazebo? Gazebo is
Okay.
nothing but it's just a simulation software. So there are these open source robots. Like I have given you the installation file, right? I will give you. So in that only there is a way to install the Turtlebot. So Turtlebot is basically a mobile robot which you can use in Gazebo. I will just open it and show you how can you use that. Okay, so yeah, you can see my screen. Okay, cool. Let me just run it. So ROS launch, Turtlebot 3, Gazebo.
Is this a part of ROS itself?
Gazebo is a software which supports ROS. Gazebo is not part of ROS. Yeah, it uses ROS, like it uses ROS to operate.
Okay, it's a software which uses ROS to operate.
Yes. So you can see here there's this mobile robot. Now similarly, let's see what are all the topics this mobile robot publishes.
Are you controlling it with the ROS app on your phone?
We can do that also. I'll just first show you what are all the topics. So ROS topic list will give you all type of topics. So you can see, I'll just give you basic command will. This is basically to control the velocity. An image, it's basically the camera. So let's see. So if we want to okay, ROS 2B graph. First I'll show you RQT graph. So in RQT graph you can see Gazebo is there. So it is not subscribing to anything or it is not publishing anything. So now in the app only, like we have the velocity, right? So over here, my command, like over there, we are publishing the velocity in a topic called joy. But over here, it is subscribing to the velocity in a topic called command well.
Okay, so here command well is a subscriber.
Command well is a topic.
Okay.
So that topic is what Gazebo is subscribing to, like the robot is subscribing to, sorry.
Okay.
So instead of joy, I'm changing my topic name to command well in my phone. Now, when I move the joystick, you can see the robot moves.
Okay.
Now imagine this robot has a individual system like 2 motors with the Arduino, where you wrote a code to publish PWM based on the data which it receives from a subscriber from command well. And this is running on a ESP32 node MCU, so it's running on Wi-Fi. So that is how in real robot it works. So that code is running on the robot. Basically, the robot runs a subscriber code, it's subscribing to command well, and based on the velocity, it's publishing the PWM values. So that is what you're simulating over here.
Okay.
Understood?
Yeah.
So now what you can do, like you can also subscribe. There are ways. I will just show you it. ROS. Let me. What else I can show you is. Okay, IMU. You know what an IMU is? No.
No.
Okay, in your phone you play NFS and all. You move your phone like this, and car moves. That is basically IMU. IMU is nothing but a sensor which will detect motion based on accelerometer and gyroscope.
Okay.
So that's how your phone is realizing when you move here, like your orientation is this. It's basically a device to identify the orientation. So you can see the IMU data published from your Turtlebot over here. Your Turtlebot has a LiDAR, so that is publishing in a topic called scan. So you can see LiDAR is basically nothing but ultrasonic sensor, but in 360 degrees. So this particular LiDAR has 3.8, that is 360 degrees with this particular range. So this is at 0th degree, this is first degree, so it has 320 points. So if you want the distance at 90th degree, you can subscribe to this message and see the 90th data of this array. That will give you the distance of the object in exact straight angle to the robot. So you can use that particular data and you can write two codes. One is publishing the command velocity goes straight. One more is just checking this, subscribing to the scan data, checking this particular value. If that value, like 1.9 means at 1.9 meter there is obstacle. So if this is less than 0.3, that is 30 centimeter, if there is obstacle, it will publish stop. So your command code will stop the robot. Like it will publish 0. So the robot will stop. When this data, then the obstacle moves, this data will again increase. Then again if statement will break because distance is greater than 0.3. Then obstacle will publish false. Then your command can publish velocity, so the robot will move forward. This is how you can use gazebo.
Okay, cool. I guess some people used this last time for their problem statements.
Yeah, I mean, if you don't have a real robot, gazebo is always a better way to do it. Like without hardware, you can actually do all kind of stuff. You can see the camera data, you can do image processing, everything you can do.
Okay, cool.
Cool. So yeah, so that's it. So this is how publisher subscriber works. You can use it in your project. Use ROS like PySerial to integrate with your hardware if you want. If you are using ROS, you can easily connect your mobile to your laptop and get data and use it for your problem statement. That's it. If you have any doubt, ask me, or else I'm leaving in next 2 minutes. Shalom.
Okay, I guess that's it. No one has any doubts.
Thank you.
You're muted.
I said bye. Good night.
Thank you.
Bye, good night. Thank you.
Thank you.
Thanks, Ruby. Good night.
Stop using your phone there.
Hey. Overall, then. Alvin, why did you call?
Alvin,
Where's Alvin? Oh, you are looking like Alvin Kaushik. Both of you have same hairstyle. And your
Very
camera
good.
clarity is so good that I can't differentiate between you two. Who is that
Very good.
sitting?
That's one of my